In the next few minutes we're going to take a look at modifying the mower deck for the IronEagle mowing machine. As we rotate the deck around, you'll see that there's a single wheel on the back of the deck. We want to replace this with a roller. We're going to start by opening up a draft file of a roller design in 2D. Notice that we have full layer control, and we can turn off the border layer. And now what we want to do is copy this geometry into the 3D environment. So just by simply fence selecting and copying it to the Microsoft clipboard, we'll be able to paste this into the 3D environment. The next thing we may wish to do is position this geometry in the 3D world. So here we're going to move all the elements from the midpoint to the base coordinate system. This will ensure that later we'll have symmetry in our model. Notice we have full layer control in the graphics window as well. Now we want to revolve this into a shaft. So just by simply dragging the steering wheel to an edge puts us in the revolve command, where we can simply select the torus and begin dragging. The shift key enables us to toggle symmetry. Notice as it revolves into a 3D model that a live section is automatically created and all of the dimensions are attached to the live section for us. That live section controls the 3D geometry, and I can change those dimensions and change the model. Because we centered this model on the base coordinate system, as we change the depth of this pocket, notice that it changes the other side because of the symmetry live rule. Next, we may want to add a drain hole to our roller. So using the hole command, we can set the diameter and also set the extent. In this case, we're going to go through the entire model. Notice that we can control the angle at which the hole will be placed on the 3D geometry. Key points enable us to precisely place it based on the live section. Now that we have our model created, we'll just save it. And next we'll begin to build an assembly. This can become the first part in our assembly by just selecting Create Assembly. We'll save this assembly to our folder structure, and then we'll begin adding new parts. From our parts library, we're going to add a bearing to each end of the roller. Capture Fit has been applied to the bearing. Capture Fit enables us to capture placement relationships to make it much faster to place in the assembly. New functionality in ST4 is the ability to copy within the assembly environment and create new relationships. So here we're going to copy a roller to the opposite end. The interface allows us to determine how we want to create new relationships. Notice the relationships that were created for us automatically. Finally, we want to add a subassembly for the shaft. Again, Capture Fit has been applied to the shaft, so all we need to do is mate and create an axial alignment to place the shaft in the assembly. Once that's saved, we'll return back to the deck. We'll in-place activate into the deck so that we can edit the deck. First we want to remove the wheel, and then we want to move the bracket on the left. We're going to move it all the way to the right and reattach it to the deck. We can suspend the animation to make it easier to see for placing to the new hole. Again, we'll allow Solid Edge to create new relationships to the deck. Next, we want to add our roller assembly. From our parts library, we can add that from the open documents. First, we're going to create an axial alignment to the hole in the bracket. Next, we want to center that roller between the two brackets. We don't have a center plane, so we'll use the double option to first find the center between the two ends of the roller and then the center plane between the two angled brackets. Notice it places it precisely centered. Obviously, we have an interference issue, so what we're going to do is change to a face selection so that we can select a face in the deck and actually move the mounting holes, which is going to in turn move the bracket that's mated and aligned to those mounting holes. This has improved our interference issue, but we want to add some more clearance. So we're going to begin to edit the bracket. This is the advantage of top-down assembly design, in that you can see the changes that you're making, how it's affecting the overall assembly. Next, we're going to add a horizontal vertical lock to the angled bracket. When we select that face, it automatically will snap to vertical. Another thing that we may wish to do is align the center line of the center point of the mounting hole for the roller to the midpoint of the bracket. Again, the new relationship that we have in Solid Edge ST4 allows us to do that very quickly and easily. This becomes a persisted relationship such that if we move the hole in the bracket, it's going to change the midpoint as well. So using the steering wheel, we'll just begin to drag that and you'll see this change. Now as we return back to the top level assembly, you'll see that we fixed the interference problem we had between the brackets and the roller. Now we'd like to copy all of this geometry to the opposite side to make another set of brackets and a roller. So again, using the assembly tools, simply select the option to copy the geometry as we're moving. Again, we can suspend the animation of the movement so that we can easily select the mounting hole. And again, Solid Edge creates new relationships to the new brackets. So there we've added our rollers to the back of the mower deck. Now as we rotate back to the front, we need to add a fastener system or a fastener stack to the front to mount that wheel. In Solid Edge we have fastener systems, which now enables us to even select a plane to define the top of the stack. In this case it's a square hole. On the opposite side we'll just define the hole, and this will determine the length of the fastener needed as well as the diameter. Now in this case it tells us that it does not have a fastener because it's an ANSI, and our fastener that we want is in DIN. So when we update the fastener system, you'll see that it provides us the M12 mushroom head bolt that we need for this fastener stack. We also need to make the bolt a little bit shorter, so we're going to make the minimum distance 2 millimeters, and then we need to add a washer to the top of the stack. On the bottom of the stack we need the nut associated to that M12 bolt, and we also need another washer. Now of course the washer has to come before the bolt, so we can just reorder that quickly. And there you can see that it placed the fastener stack for us automatically. So this finishes up the design on the deck, and we're going to close and return back to the top level assembly, and we're going to change our configuration to concentrate on the lever arms for driving the lawnmower. Now we get a warning because a part has been deleted, and that's because the roller was deleted, the wheel was deleted out and replaced with a roller. So we just want to remove that wheel from all the configurations. Solid Edge is a nice tool for doing that. Now what we'd like to do is create a range relationship on the hydraulic cylinder, which is controlling the arm. So the first thing we'll do is in-place activate into the subassembly where the cylinder resides. As we select the cylinder rod, you'll see the relationships that have been applied to that cylinder rod. It has an axial alignment, and it also has a mate to the bottom of the hole in the cylinder itself. That is a 20 millimeter offset. We're going to change this to range, and we're going to specify a range, a minimum range of 5 millimeters and a maximum range of 75 millimeters. What this does is limit the range at which that cylinder can move. So as we use the tool in Solid Edge to drag component, we can drag the cylinder rod to see how far it will move. So as we drag, we get to the furthest extent, the 75 millimeter offset from the bottom of the hole, back to the 5 millimeter offset. Once again, you can see the range of motion. So you see Solid Edge has nice tools for creating a range.